In this video, we're gonna still be talking about dividend discount model. However, we'll expand to the special case non-constant growth model, which is also called two-stage model. In this case, the dividends are not growing at G forever anymore. Instead, we have two stage. Okay, in class 1, we have the case where we only have one stage, and the G is constant forever. Here, we call it non-constant growth model because G is not constant forever anymore. We have two stage, where in the first stage, we have a dividend growth rate G1, and then in the second stage, we have another different growth rate G2. Okay, so things get a little bit more complicated. We will have 3 steps working on such problems. Step 1, calculate dividend D1 from Dn plus 1. N is the last year of the non-constant growth model period, the horizon date. Step 2, calculate horizon value Pn, stock's price at the end of the non-constant growth period. Step 3, calculate P0. Calculate cash flow and NPV function can help you get present values of dividends and horizon value. Inputs are CF1 equals to D1, CF2 equals to D2, CFN equals Dn plus Pn. Okay, you might be a little bit confused about the terminology we have here, but we'll discuss all these new terms and new steps in detail. We will also calculate dividend yield and capital gains yield for this two-stage model or non-constant growth model. For the first year, we can still use our conclusion we had from last class that dividend yield equals D1 over P0. Okay, based on the dividend yield definition. For capital gains yield of the first year, we can use R, the total return of the stock, minus the dividend yield. So we have capital gains yield. Okay, so we can, for the first year, we can use the definition of both to calculate both of them. If non-constant growth, dividend yield and capital gains yield are not constant, and capital gains yield doesn't equal to G. However, after year N, the stock has constant growth, and dividend yield equals R minus G, while capital gains yield equals to G. So even this is a non-constant growth model where we have two stages, but it's usually in the second stage that the firm becomes mature and stable, and we have a constant growth of G after N years. So we can still use the two conclusions we had from last class that dividend yield equals R minus G and capital gains yield equals to G in the constant growth model setting. Okay, so for the second stage, we can still treat it as a constant growth model. It's just in the first stage, we may have a much faster G because this firm is just at the starting point, and usually they have a faster growing rate compared to a mature firm. Okay, so we will calculate the stock price for non-constant growth model setting for a firm that starts at a higher growth rate and then becomes mature and have a constant growth rate in the second stage. We will also calculate dividend yield and capital gains yield for the firm in each stage. Okay, here shows us the graph of what kind of case non-constant growth model applies to. In last class, we were talking about constant growth model. We have case where G is 0. We have 0 growth all the time. We have normal growth rate when G is larger than 0. For example, 8%. We have a constant growth rate G as 8%. We have the case when G is smaller than 0, where we have G as a constant growth rate as negative 8%, for example. So we have a declining growth all the time. Okay, for all of these 3 cases, we can use the constant growth model setting, and P0, the estimated stock price, equals D1 dividend of the first year, or at the end of the first year. divided by RS, stock return, minus G, growth rate of the dividends. Okay, G is also growth rate of the price. It is also the capital gains yield. Okay, so R minus G is dividend yield equals to D1 over P0. Okay, we can also get RS from CAPM or from this model. We can also get G from all the other three variables from this model. Okay, these are what we learned last class. So for this lecture, we're going to focus on this first line here. Where we have non-constant growth model. Okay, two-stage model. In the first stage, it's usually supernormal growth. It can be as large as 30% growth rate, G. In the second stage, okay, the firm becomes more stable and mature, and the growth rate could be just a normal growth of 8%. So in the second stage, we can still use what we learned from the constant growth model setting to calculate the discount value of the dividends. Okay, but in the first stage, we have to discount the dividends one by one because it has a much higher growth rate. Okay, and the dividing point of the two-stage, we will call it horizon date, and it is at the end of the supernormal growth period and the beginning of the regular growth period. Okay, well, let's look at an example here. What if we have a G equals to 30% for 3 years before achieving long-run growth of 6%? So here is a typical example where we have a two-stage. First stage, G1 equals to 30% for 3 years. In the second stage, G2 equals 6% for all the years after the third year. We also know that D0 equals to 2. Okay, the dividends are just given out in the beginning of the first year, and it's $2. Stock return, RS, is 13%. Okay, in this case, we can no longer use just the constant growth model to find stock value. Constant growth model only applies to the second stage. However, the growth does become constant after 3 years. Okay, so the dividing date is 3, n equals to 3. First, we assume that the dividend will grow at a non-constant rate, generally a relatively high rate for n periods, after which it will grow at a constant rate G. So this dividing date n is called horizon date or terminal date. After this date, we have a constant growth rate. Before this date, we do not. Second, stock's horizon value or continuing value will be n periods from today. Okay, so the stock's value at the horizon date, Pn, is called horizon value. Okay, and for Pn, because after n years, it is all constant growth rates, so we can use the constant growth model to calculate Pn. Okay, it is Dn plus 1, the dividend given next period, divided by R minus G. G is the growth rate in the second period, or the second stage, and it is constant forever from date n. Finally, the stock's intrinsic value today, P0, is the present value of the dividends during the non-constant growth period, the first stage, plus the present value of the horizon value. Okay, so for horizon value, it is the discounted value of all the dividends in the second stage to date n. So after we use constant model, count all the dividends in the second stage to date n, we can discount it to present to time 0 again. And we also discount all the dividends in the first stage to present. Add them up, we will have all the discounted value of all the dividends to present. And that's the stock price today. Okay, so P0 becomes, first we discount D1, D2 to Dn. Okay, that's the discounted value added together for the first stage. For the second stage, dividends start from Dn plus 1 and goes on forever. And all these discounted value to time n is Pn. Okay, Pn equals to all the discounted value of the dividends in the second stage. And for Pn, we can divide by 1 plus r to the power of n to discount it to present to get part of P0. Okay, so P0 end up to be all the dividends from D1 to Dn in the first stage, discounted to present, plus Pn, the horizon value, discounted to present. Okay, and Pn here equals Dn plus 1 over Rs minus G. Again, it's using constant growth model in the second stage. Okay, and Pn divided by 1 plus r to the power of n would become Dn plus 1 over Rs minus G, which is Pn. And the denominator multiplied by 1 plus r to the power of n. Okay, so we use constant growth model to discount all this dividend to in the second stage to time n. So we have Pn. And then we discount Pn, also discount all the dividends in the first stage, so we have P0. These may look a little bit abstract for you, but let's look at this specific example so you could be more clear about this case. Okay, again, we know the D0 is 2. We know Rs is 13% from the question. We know that G1 equals to 30% for the first, second, and third year. But from the third year, after the third year, we have G2, the constant growth rate of 6%. Okay, step 1, we need to calculate dividends from D1 to Dn plus 1. Here, n is the last year of the non-constant growth model, the horizon date, and it is 3 in our example. So we calculate D1 to D4. Okay, we know D0 as $2 given. We know G1 as 30%. So D1 equals D0 multiplied by 1 plus 30% as 2.6. D2 is D0 multiplied by 1 plus G1 square, 3.38. Or it could be this 2.6 multiplied by 1 plus 30%. D3 is D0 multiplied by 1 plus G1 cube, 4.394. It could also be the D2 value multiplied by 1 plus G1. Okay, these are the dividends in the first stage. D4 is special because after 3 years, we have G2 as our growth rate. So we can use D0 multiplied by 1 plus G1 cube multiplied by 1 plus G2, which is also D3 multiplied by 1 plus G2. Okay, in the second stage, we use a different growth rate. So we have 4.658 as D4. And we mark all of these dividends on our timelines. D0, D1, D2, D3, D4. Okay, this is step 1, calculating from D1 to Dn plus 1, which is D4 here. Step 2, we're going to discount all the dividends in the second stage to get Pn, the horizon value, which is P3 here. We're going to use constant growth model, which is D4 over Rs minus G2 for the second stage. So we discount all the dividends to time n, time 3 here. Okay, and the step 3 would be discount D1, D2, D3, and P3. to present, add them up. So we have P0. Okay, step 2, calculate horizon value Pn, stock price at the end of the non-constant growth period, or the dividing dates between the first and second stage. Okay, so it could be the stock selling price too after 3 years, or the stock value after 3 years. So the horizon value here equals P3, and it is D4 over RS minus G2. Okay, we use constant growth model for the second stage. D4 is 4.658 calculated out already. Divide by R, 13% given, minus 6%, G2 in the second stage. Okay, so we have horizon value P3 as 66.54. Step 3, calculate P0. Calculate cash flow and NPV. Calculators, cash flow and NPV function can help us get present value of all the dividends in the first stage from D1 to Dn, and horizon value Pn. Okay, so our last step is to discount all the dividends in the first stage, which are D1, D2, D3 in our case, and horizon value P3. Okay, so we need to input cash flow 1 as D1, cash flow 2 as D2 in the financial calculator, and cash flow n as Dn plus Pn. So here we can input cash flow 1 as D1, cash flow 2 as D2, cash flow 3 as D3 plus P3. Okay, we discount D1, D2, D3 because we need to discount all the dividends in the first stage. We discount horizon value P3 because it is the discounted value of all the dividends in the second stage, 2 times 3. So now we want to discount it to times 0. Okay, and because D3 and P3, they occur at the same time, so we can input them together as cash flow 3. Okay, do you remember our cash flow function in the calculator? We can go to cash flow function. We input cash flow 0 as 0. Okay, remember when we discount all the dividends in the first and second stage, we do not include D0. D0 is something that's already paid at time 0. If we're trying to get P0, we're trying to purchase the stock right now, we do not have this D0 anymore. It's already paid. It's paid at the end of last year, which is the beginning of this first year. Okay, it's already paid. So cash flow 0 should be 0. Enter down button. Cash flow 1 should, frequency 1 should be 1. Okay, cash flow 1 should be 2.6, the value for D1. Enter down button. Frequency 1, down button. Cash flow 2, 3.38. D2. Enter, down button, cash flow 3, we input D3 plus P3. Okay, again, cash flow 3 means the cash flow that occurs at time 3. We have two flows here, D3 4.394, P3 66.54, so we add them up, okay, equal sign, enter. Then we go to NPV function, input I as our stock return, the discounted rate here, 13, enter, down button, and we go to NPV compute. So we have 54.11 as our stock price here, okay, P0. If you can also calculate these discounted value manually. If we use D1, 2.6 divided by 1 plus R, 13%, we have 2.301. If we discount D2 by using 3.38 divided by 1 plus R to the power of 2, 1 plus 13% square, we have 2.647. For D3, 4.394, we can divide by 1 plus R cube, 1 plus 13% to the power of 3. So we have 3.045. For P3, okay, first we calculate it by using D4 over RS minus G2. So we have 66.54. And then we divide by 1 plus 13% cube. So we have 46.114. And then we add these four numbers up. So we have P0 hat as 54.107. Okay, you can discount D1, D2, D3, P3, these four flows manually, or you can use our cash flow function on the calculator. Okay, so you can see that I just have the BA2 Plus Texas Instrument Financial Calculator emulator on the screen. Okay, I'm gonna show you how we can calculate P0 by using this financial calculator. Okay, this is helping you to review the cash flow function in NPV. Okay, so we press cash flow function first. I'm at CF0. Okay, again, it should be 0, so we just press down button. For cash flow 1, we input 2.6. Okay, enter, down button. Frequency should be 1, down button. Okay, we go to cash flow 2. It should be 3.38. Enter, down button, down button. Cash flow 3, it should be 4.394 plus 66.54. I first use this equal sign, so this equation is calculated arithmetically, and then I press enter. So I can input cash flow 3 as 70.934. Okay, you can see a triangle showing up here, meaning the cash flow 3 is input properly. Okay, now let me double check by pressing down button. Frequency 3 is 1, down button, there is no cash flow 4 or frequency 4, and I come back to cash flow 0, make sure I only have 3 cash flows input. Now I go to NPV function, I input IS13, enter, down button, then I come to NPV, and the screen reminds me I can press compute. Okay, I have 54.1087 as my P0, which is about 54.11. Okay, let me minimize this calculator window and continue with this example about how we can calculate dividend yield and capital gains yield for both stage. For the first year, because it's not in a constant growth model setting, so we can only use our definition for dividend yield and capital gains yield. For dividend yield, by definition, it should be D1 over P0. We know both numbers, so we can just plug the numbers in, and we have 4.81% as our dividend yield. For capital gains yield, we use our definition that, well, of course, the original definition for capital gains yield is equal to P1 minus P0 over P0. But we also know the definition for total return of the stock equals dividend yield plus capital gains yield. So capital gains yield is just the total return minus dividend yield. Okay, we know both of them, so we can know capital gains yield as 8.19%. In non-constant growth, dividend yield and capital gains yield are not constant, and capital gains yield does not equal to G, especially for the first stage. However, in the second stage, after 3 years, the stock has constant growth and dividend yield becomes R minus G, 7%, while capital gains yield becomes 6% G. Okay, so in the second stage, we can just use the two conclusions we had for dy and CGY in the constant growth model setting, that dy is d1 over p0 is r minus g. CGY, capital gains yield, is the same as the growth rate of the dividend, same as the growth rate of stock price, which is G. Okay, so that's how we work on two-stage questions to calculate P0 and dy and CGY. In the next video, I'm going to talk about another example of how we calculate P0 in non-constant growth model setting. Okay, so before moving on to the next video, make sure you understand everything in the first example. And before looking at the solution for the second example, you can try to do things yourself to see, try to figure out what is the stock price if G is 0% for 3 years. So G1 becomes 0%. And our long-term growth rate in the second stage is 6%. So G2 is 6%. Okay, so N is still 3 and R is still 13%. D0 is still $2. Okay, try to work 3 steps for this example 2. Step 1, you still need to work on figuring out what is D1, D2, D3, and D4. Step 2, you calculate P3. Step 3, you calculate P0. Okay, we're going to talk about the solutions in the next video, but you could work on this question yourself before looking at the answers. All right, I'll talk to you in the next video.